Harvard and NASA warn 3 I/A/TLAS could hit Mars. The data is terrifying. The calm before the storm. For months, the world watched in awe as 3 I/A/TLAS, the third interstellar comet, glided gracefully through the outer solar system. Discovered on July 1, 2025, by NASA's Atlas survey, it was hailed as a cosmic gift, a frozen messenger from another star, offering clues to the chemistry of alien worlds. Scientists predicted a harmless flyby just inside Mars orbit on October 30th. No threat, no drama, just science. But that story ended on August 12, 2025. The first anomaly. It began with a whisper in the data stream from the Mars Reconnaissance Orbiter MRO. The comet's coma, its glowing halo of gas and dust, had doubled in brightness overnight. Not gradually, not randomly, instantly. And embedded within that glow were ultraviolet spikes, sharp, energetic, and repeating. Dr. Elena Voss, MRO's lead imaging scientist, flagged it immediately. "This isn't sublimation," she told her team. "This is pulsing." Harvard sounds the alarm. Within 48 hours, Professor Avi Loeb and his team at Harvard's Galileo project released a preprint that sent shockwaves through the scientific community. Their analysis of JPL's trajectory data revealed something impossible. 3 I/A/TLAS was accelerating, not from solar gravity, not from outgassing chaos, but from deliberate, rhythmic thrusts, one every 17 minutes, like a cosmic metronome. "Natural comets don't behave like this," Loeb stated in a closed-door briefing. "This is guided motion, the speed that breaks physics." By mid-August, 3 I/A/TLAS was clocked at 87 kilometers per second relative to the Sun, nearly 30% faster than any known interstellar object. At that speed, it could cross the Earth-Moon distance in 78 minutes. But speed wasn't the real terror. It was the precision. Every micrometer per second adjustment from Jupiter's or Mars' gravity was being countered, amplified, or redirected by internal forces no one could explain. The 17-minute pulse. The Gemini South Observatory in Chile captured the smoking gun, spectroscopic data showing gas ejections timed to the second. Every 17 minutes, a plume of superheated CO2 and nickel-rich vapor erupted from the nucleus, always in the same direction, always with the same force. "In 40 years of comet science, I've never seen rhythm like this," said Dr. Carlos Mendez, Gemini's lead spectroscopist. "It's engineered. The new trajectory." JPL recalculated the orbit. The results were chilling. Instead of a safe pass at 1.4 astronomical units, 3 I/A/TLAS was now on a path to cross Mars's orbital plane on September 26, 2025, at a distance of just 1.95 million kilometers. For context, Phobos, Mars' inner moon, orbits at 9,400 kilometers. This was close enough for Mars's gravity to tug it off course, or for a small nudge to turn a flyby into a collision. The energy gap critics argued sublimation can't produce that much thrust. They were right. To change velocity by 10 kilometers per second, the threshold for impact would require 10 billion joules of focused energy. No comet outburst in history has released even 1% of that. Yet the trajectory demanded it. The only explanation? An internal power source, possibly fusion, antimatter, or something beyond human physics. Radar echoes from the core NASA quietly repurposed the Goldstone Deep Space Network. High-power radar pulses were bounced off 3 I/A/TLAS nucleus. The return signal wasn't soft and diffuse, as expected from ice. It was sharp, metallic, layered. One insider described it as like scanning a spaceship wrapped in ice. The triangle over Mars. On August 28th, ESA's Mars Express captured 3 bright glints in high orbit, arranged in a perfect equilateral triangle. Dismissed at first as cosmic rays, they reappeared on 3 consecutive orbits. Loeb urged NASA to cross-check with MRO's archives. Within hours, matching thermal signatures were found on Mars's surface, 3 metallic fragments, half buried in the regolith. If real, Loeb said, this is the first evidence of interstellar technology. The impact scenario JPL ran the simulations. A direct hit by 3I/ATLAS, estimated at 10 billion tons with a 400-meter metallic core, would release 2 million megatons of TNT equivalent. The crater, 60 kilometers wide, 5 kilometers deep. The ejecta, millions of tons of rock flung into space. The aftermath, Perseverance, Curiosity, MRO, Tianwen-1, all destroyed. Decades of science erased in seconds. Planetary Defense activated leaked memos revealed emergency task forces convened by NASA, ESA, CNSA, and JAXA. For the first time in history, agencies discussed intercepting an interstellar object. Options included kinetic impactor, like DART, but faster. Nuclear deflection, controversial but on the table. Reconnaissance drones launched from Mars orbit, all remained classified. The Green Beam's amateur astronomers worldwide reported something eerie. 3I/ATLAS tail had split into 3 needle-thin streams, glowing emerald green. At long exposure, the beams converged toward Mars, pulsing in sync with the 17-minute cycle. It looks like it's painting a path, said one observer from Chile. The autopilot hypothesis Loeb and his student Adam Hibbard published a new paper. 3I/ATLAS is a derelict probe launched millions of years ago by a civilization far more advanced than ours. Its ice shell is sacrificial shielding. Its gas pulses are reaction control thrusters. Its mission: deliver cargo to Mars or test humanity's response. It's not alive, Loeb said, but it's awake. The silence from NASA publicly, NASA issued calm updates. No threat to Earth. Routine observations continue. Privately, mission control was in crisis mode. The disconnect bred paranoia. Was NASA hiding the truth or buying time? The September window. September 19th to 30th, 2025, the critical period. If the 17-minute pulses continue, 3I/ATLAS will close the final gap to under 50,000 kilometers, closer than Deimos, Mars' outer moon. One major outburst during this window could tip it into collision. The cosmic needle astronomers began calling it threading the eye of a cosmic needle. At 57 kilometers per second relative to Mars, even a glancing blow would vaporize cubic kilometers of rock and inject debris into interplanetary space. Some models showed fragments reaching Earth's orbit within a decade, carrying who knows what. The nightmare scenario. What if the core contains self-replicating nanobots, or engineered microbes designed to terraform or infect? Mars is barren now, but if seeded with alien biology, it could become a biohazard spreading through the solar system. The world watches. By early September, every major telescope, Hubble, Webb, VLT, Keck, was locked on 3I/ATLAS. Social media exploded with hashtag #MarsImpact. Governments prepared contingency plans, and ordinary people looked up at the red star in the sky and wondered. The final question: is this a natural anomaly, a comet behaving in ways we don't yet understand? Or is it the first undeniable proof that we are not alone? As Loeb put it, the universe doesn't send metronomes, it sends messages. The threshold. On the night of September 25, 2025, the world holds its breath. Above Mars, an icy wanderer pulses its green exhaust, adjusting its path meter by meter. It is not a rock, it is not random. And in less than 24 hours, it will either fly past in silence or rewrite human history with a single impact. We are no longer just observers. We are witnesses to a cosmic threshold. And whatever happens next, we will never see the stars the same way again.